Welcome back. We're going to start to wrap up this mini unit here, chapter 12. We're going to start section 3 in chapter 12. Our target for today is simply to write a rule, which is an equation, for a geometric sequence. So, identifying a geometric sequence. Sequences must have a common ratio for geometric. So, we added the same number over and over again for arithmetic. For geometric, it's common ratio. So each term divided by the previous term gives you the same ratio. So A2 divided by A1 is the same ratio as A3 divided by A2 is A3 divided by, A4 divided by A3, etc., etc. So is this sequence geometric? Well, to test it, we take 8 divided by 4, we do 16 divided by 8, we do 32 divided by 16, we do 64 divided by 32. So 8 divided by 4 is 2, 16 divided by 8 is 2, 32 divided by 16 is 2, 64 divided by 32 is 2. Is this sequence geometric? Yes. And our common ratio is 2. Is this sequence geometric? Well, let's see, negative 4 divided by 1, that's negative 4. 16 divided by negative 4, that's negative 4. 64 negative divided by, divided by 16 is negative 4. And 256 divided by negative 64, that's negative 4. I would say yes, this one is as well. And R is negative 4. Is this one geometric? Let's see, 128 divided by 512. Put that in your calculator, reduce it, you get 1/4. You get, let's see, 128 divided by 512. Oops, just did that one. 64 divided by 128. That's going to be 1/2, so we already can see it's not. We can keep going for one further. 8 divided by 64, that's 1/8. So the answer is no. There's no common ratio here, not geometric. So, what does a geometric sequence look like? It looks like this. A sub n equals A sub 1 times R to the n minus 1. These terms are going to be familiar. R, this is the new one, it's a common ratio. Kind of brought that up in previous slides. A sub 1, that's still the first term in the sequence. A sub n, it's the nth output. It's the y values. And n is the input. I think that's the values. Okay, so let's look at a sequence and write our rule for the nth term. Okay, so on the test, I'm not going to tell you necessarily what type of sequencer it is. It could be geometric, arithmetic, or it could just be a general pattern, and you have to find the rule yourself, like we did in section 12.1. So I always look, though, to see if it's one of the easy ones, arithmetic, like we did last chapter, or last section, or geometric, like we're doing now. I'll make it clearly see that this is a difference of 12, then a difference of 60. It's not arithmetic. So I'm going to look and see if there's a common ratio. And it looks like if we multiply by 5 all the way across, we kind of go from one value to the next. So A sub 1 is 3. That's our first value. Our R is 5. So we can plug into the equation and find the model. A sub n equals 3 times 5 to the n minus 1. There's no simplifying here. This is the nice part about this one. You just plug it in, that's your equation. If I want to find the 8th value, then I just say, okay, A sub 8 equals 3 times 5 to the 8 minus 1. I can plug that in my calculator. 3 times 5 to the 8 minus 1. Well, that's really 7, but if you just literally type it in, it'll do it for you. And we get 234,000 375. So that's how you develop or find geometric models or geometric sequences. Okay, I debated about even going over this one, but I thought it'd be a good idea because sometimes people like to switch things around to make it fit better for what they want it to be as far as R instead of what it really is. Notice our values, even though they're oscillating back and forth, the actual number, if you think of the absolute value, is decreasing. It's getting closer and closer to 0 each time as we oscillate back and forth because it's a sub 2 divided by a sub 1. So it's not negative 3 that's the ratio here, it's negative 1/3. So keep that in mind. Because if you put negative 3, obviously your values are going to be off. So our ratio is negative 1/3. Our a sub 1 is 972. And we have negative 1/3 times, excuse me, vice versa, 972 times negative 1/3 to the n minus 1. There's our model. Our second part is find the eighth term. We just plug 8 in. We plug that in, and we can plug it in our calculator. 972 times negative 1 over 3 to the 8 minus 1, which is negative 0.44. If we hit math fraction, we get negative 4/9. So as you can see, it's getting closer and closer to 0 as we go out forever and ever and ever. The values are getting smaller. Start out really big, and the eighth value already between 0 and negative 1. Okay, of course, we're going to find finite sums of a geometric series. That wasn't on the target for today, but this is a bonus. Okay, so write this down. So if it's a geometric series, the formula a sub 1 times 1 minus r to the n over 1 minus r will give you the sum, or the nth sum, nth term. So n is the number of terms we're looking at. A sub 1 is still the first term, and r is your ratio, your common ratio. So here is our sum. We'll do the formula once, we'll do the calculator once. Okay, so n, well, it starts at 1, we go to 8. So here, n, that's our 8th term. And our r, well, that's going to be negative 2. And so now we just plug into the equation here. A sub 1, well, our first term, that's a sub 1 right there. That's 6. So we type in 6 times 1 minus negative 2 to the 8th power, all divided by 1 minus a negative 2. Lucky for us, we have these lovely calculators. They have a fraction mode on them. Oops. Alpha equals fraction. And we're going to do 1 minus a negative 2 to the nth power, which is 8, divided by 1 minus a negative 2. And I hit enter, and I get 17/3. I just realized I forgot to multiply this by a sub 1. A sub 1 is 6. So we want to multiply this whole thing by a sub 1. My bad. So I plug that in there, and we get 34. Oh, oops. I see where we messed up. Shouldn't be 34. I did negative 2 times 8 this, and it should have been negative 2 to the 8th power. Oops. First mistake of the whole year. We get negative 5. That's what I was looking for. So obviously it makes a big difference if you start hitting the keys too fast and forget the power key. So the 8th power is way different than the multiplying by 8. So negative 510 should have been our answer. Now, we can do this on the calculator as well. Alpha window 2. And we get x equals 1. We go up to here, we put 8. We go into the rule. 6. Now we're going to need the x parentheses here. Negative 2. It's at 22. Negative 2 to the power of x. The power key, almost did it again. Power of x minus 1. And we hit enter. And we get negative 510. So that formula is nice, but if we have our graphing calculator, we don't even really need it. Okay? So I think we hit our target for today. We even got a bonus one you can add in there that we found the sum of finite geometric series as well. And have this in your notes. Be ready for tomorrow. Practice, 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 and really fast. Have a good day.